Today we shall discuss regarding voltage follower regulator. So you can observe here voltage follower regulator. So we are giving non-inverting terminal. For non-inverting terminal, Zener diode is connected. So here the op-amp supply terminals are connected to the regulator supply voltage. So op-amp supply is plus Vs and ground. So op-amp supply is what we are giving is that is Vs and ground with the op-amp inverting input terminal connected to the output. If you observe the circuit, so this is the non-inverting terminal and this is the inverting terminal which is connected to the output. Okay, V0. So V0 will remain close to the Vz. That is the main function of series pass transistor Q1 is to provide what? It is to provide a load current larger than the maximum supplied by the op-amp. And here, so inverting terminal is connected to the V0 and non-inverting terminal is connected to the Zener diode D1. If you observe, okay. Here, op-amp is used as a comparator. Op-amp is used as a comparator and op-amp supply voltages are plus Vin and ground, we can say. Here, VB equals to V0, that is V output voltage. That is input voltage equals to output voltage and VA equals to VZ. That is VA equals to VZ, Zener diode voltage. And VB equals to VA, that is V0 equals to VZ. The series pass transistor which we have used here, okay. Only op-amp cannot supply the large current. So we have used additional here, that is a transistor, service pass transistor in order to supply a additional load current. Okay. In order to supply the load current, the series pass transistor is used to supply the additional load current. Okay. Additional load current which op-amp can not supply, okay, which op-amp cannot supply. So we are using a series pass transistor in order to supply the additional load current. So for large current, op-amp has to supply the IB. That is, if IL is, that is load current is less than 25 milliamps, then series pass transistor, that is Q1, does not play any role and op-amp behaves as a voltage follower. If the load current is less than 20 milliamps, 25 milliamps, then Q1 will does not play any role. Okay, so only the op-amp will work. Op-amp will behave as a voltage follower. In this case, if it is greater than, then only it is a op-amp transistor will supply the current. C1 is large capacitor of the order of 50 to 100 microfarad. C1, how much they are using capacitor? 50 to 100 microfarad. Why we are using the C1 means to help supply fast demands on regulator and to eliminate the possibility of any oscillator behavior of the regulator. Why we are using C1 means in order to supply fast demand on regulator and in order to eliminate the possibility of any oscillatory behavior of the regulator. That's why we are using a C1 and here series pass transistor we are using to supply a additional load current. These two parameters you remember, and here for non-inverting terminal a Zener diode is connected and for the inverting terminal we have connected to the capacitor and it is nearly to the output voltage. Here the supply voltages are V in and ground. Here the op-amp 741 can be used for the circuit. Here the heat sink must be provided to series fast transistor. We need to use what? We need to use a heat sink. We need to use because it will be an additional load current will be passing high load current. So the heat sink must be provided to series pass transistor. The minimum VC required to keep Q1 operating is about V voltage, that is delta IZ equals to delta Vin divided by R1. So delta V naught equals to delta Vz equals to delta Iz into Z into Z. Z, Z suffix Z, that is nothing but a dynamic impedance of a Zener diode. It is a Z suffix Z is nothing but a dynamic impedance of Zener diode. Delta V naught can be written as delta V in into Z divided by R1. That is line regulation equals to, we can write it as delta V naught for specified change in V in into 100 divided by V naught. Load regulation can be written as delta V naught for maximum change in IL into 100 divided by V naught. And here RS is a source resistance. Delta V in can be written as IL max into RS, and delta V naught can be written as IL max into RS into Z suffix Z, that is dynamic impedance of a Zener diode divided by R1. And ripple rejection can be written as a formula, that is 20 log VR out divided by VR in, that is in terms of decibel. Ripple rejection VR out equals to, can be written as VR in into Z suffix Z divided by R1. So these are the formulas which we use in the fault voltage follower regulator. So when we come to the problem, they have given a source, that is Vs 25 voltage, Rs 20, R1 470, Vz 15, Zz 10, IL max 75 milliamps. Analyze the circuit to determine the line regulation, load regulation, and ripple rejection. So delta V in is 10% of Vs, that is delta V in is 10% of Vs, 0.1 into 25. So Vs is 25, 0.1 into 25, that is equals to 2.5 you will get. And delta V naught, what is the formula for delta V naught? What we have written here, IL max Rs into ZZ divided by R1. So delta V in into ZZ divided by R1. Delta V in can be written as what? Delta V in is 2.5. Instead of writing IL max into RS, we have written directly delta V in. So 2.5 into 10 divided by 470, which they have given in the question only. That after substituting, you'll get 0.05319. And line regulation, what is the formula? Delta V naught into 100 divided by V naught. Delta V naught, we got 0.05319 into 100. V naught value, how much they have given in the question? V naught value is, they have given Vz is 15 hertz. 15 voltage, that is Zener voltage. Vz equals to 15, that output voltage we have considered here. So line regulation is 0.354%. And next IL max. IL max, how much they have given? IL max is 75 milliamps. So V naught, delta V naught equals to IL max into RS into ZZ divided by R1. So from that 0.03191 V. And load regulation equals to delta V naught into 100 divided by V naught. So if you substitute and calculate, you'll get 0.2127%. And VR out equals to VR in into ZZ divided by R1. VR out divided by VR in equals to ZZ divided by R1. Z value is 10 and R1 value is 470. You'll get 0.02127. And Whipple rejection formula 20 log, right? What is the formula? 20 log VR out divided by VR in. So VR out divided by VR in value, substitute and calculate, you will get minus 33.442. So you remember delta V naught, how to find out delta V naught in terms of IL max and also in terms of the IL regulation. So if you observe delta V naught for specified change in V in, okay. So delta V naught formula, different formulas are there. Delta V in into ZZ divided by R1, that is one formula, and delta V naught, that is for the load regulation. If you want to calculate the load regulation, then delta V naught equals to IL max into RS into ZZ divided by R1. This we need to use here, okay? Because we have written here delta V naught for maximum change in IL. Okay. This is about the voltage follower and the problem. In next class, we shall discuss with the other topics.